Hi, I'm Phil, and today we're going to look at a VA meter. V stands for voltage, and A stands for amps. So this is able to measure both simultaneously, and so you can not only measure independently the voltage and the current, but you can also measure energy and power. So let's go and have a look at what this is. So on the mind map, we can see a picture of the VA meter and the connections. So it not only has USB connections, but it's also got the standard uh, jack or screw connections that you can plug in on a wider voltage range. And it uses a computer, the M5 Stamp S3, and it's got two INS226 current and voltage measurement circuits. And it has firmware built in, uh, and it uses an encoder to select menu values, and there's also a switch for that. The cost-wise, it's just under $30, and I got this about 3 weeks ago. And the applications, well, I think the most important one is for power testing of circuits and doing analysis. A good example is if you've got a new solar power system and you want to analyze its performance, you could use this as a means of collecting the data. So besides being a VA meter, you can use it as a data logger on a lot of your projects. And so the features, uh, it's got a very high precision current detection, better than you'd get from some of the competitors. The voltage range, a much wider range than you would normally get, except if you use separate volt and amp meters. But this bundles everything together in a very convenient package, which you can integrate into your experimental circuits. Okay, so perhaps a little bit more on the specs. Um, with the memory wise and communications, it has Wi-Fi and it is capable of remote monitoring. There's the screen, the load. Well, you can get up to about 5 amps. So that's the maximum current you'd put through it. Current measurements, accuracy, and we've already spoken about the user interaction. And the mounting wise, it can go onto a DIN rail and it has connections for that. It's open circuit, so you can actually see the schematic. And programming wise, well, there's not a lot here other than the firmware that comes, and you can reload that into your computer. I've upgraded the firmware over Wi-Fi. And the only other software is Microsoft Excel. So I've only done one project, and it's a continuation of what we were doing on the Christmas tree and determining how many lights we can put on that. So here is my arrangement. I'm looking at uh, varying loads. And so what's going to happen is that the current is going to change depending on your programming, the color of the LEDs, how long, and energy-wise, it depends on how long the LEDs are on for. So the objective here is to measure current and voltage. And for current, I'm interested in the average over 1 second and over 1 minute. And also I would like to know about what the peak current. So that could be quite useful in determining transients. Background wise, well, if we actually look at what the manufacturers, if we were to use uh, M5Stack, that unit belongs to M5Stack. We might actually put it in with the M5Stack. If we use NeoPixels from M5Stack, we can see that we're up to, for green, 109, and we're doubling that if we go to red and blue, and white is much more at 568 milliamps, and that's full brightness over 37 LEDs. And you can go and actually look at what the recommendations are from the manufacturer when you're looking at other arrangements. So in the LED strips, we're talking about 18 watts per meter, where we've got 60, we've got currents of 60 milliamps, which is much slower than the other one that we've just looked at. We look at Seed Studio, and the one we're actually going to use is the 30 LEDs in a strip over a meter, and we've got 30 there. And the recommendation is that we probably should be using an extra power supply and don't run our current for the LEDs through the computer. So on a Arduino Uno, the maximum that we can put is 200 milliamps, and for some LED circuits, that's just not enough. Here are some of the other LEDs that you might like to consider. Single LEDs, circular and linear arrangements. So in this project, I'm going to use the M5Stack VA Meter. So it comes from M5Stack, and I'm going to use from Seed Studio, I'm going to use the Seed Studio Nano, which is Arduino Nano compatible, not only pin to pin, but also in its power performance. And I'm going to put that Nano computer onto a carrier so that I can easily plug in Grove peripherals. And one of those peripherals is going to be the LED strip, where we've got 30 on the circuit. Software-wise, well, I did upgrade the software, the firmware, but there's not a lot of programming you can do. And I'll be using Microsoft Excel. So let's have a look at the results. So I've got a circuit, and I'm going to put it under no load. And under no load with 30 LEDs, we can see a waveform. So it's similar behavior to an oscilloscope, but not as much detail in the waveform. And you can get, these are the measurements. I prefer this display because it doesn't flicker, and you can easily see it and understand the results. So under no load, we're getting an average over 1 minute, just under 22 milliamps. And if we actually put the, let's have a look at it, that indicates the current. So there's, it's only current from the Nano computer. Under load, once we actually add our NeoPixels, we get a different result. And the current there is, let's see if we can find it. Yeah, here we go. It averaged 144, so it's actually jumping up. And we're exceeding the manufacturer's recommendation, but there's been no damage done. And here's the results. I've collected the data on the VA meter, and I've sent it across to Microsoft Excel. So you switch the VA meter into MSC mode, and you can transfer the data that you've recorded across. So here you can see that we've got a nice steady voltage at 5. That's the top line. And the bottom line is how our current changes And because we're flickering and changing the pattern under program control, our current is also changing. And let's have a look at overall. The overall experience has been quite good. And I'll certainly recommend the unit. So let's have a look at the critique of it. The good points, it's very accurate. And if you compare it to the competitors on any of these, it has a better performance. And I think the best one is the wider voltage range. So you're not only monitoring your USB power, but you can monitor other power levels if they're higher or even lower. Current and voltage wise, well, you're getting better accuracy, and particularly better accuracy on the voltage. Okay, so it's got recording and the data is available, so you can easily analyze that in Excel. So you've got various circuits there that you can use, and you've got a user interface that can give you some analysis even before uploading to your computer with Excel. Well, what about the bad points? I think the disappointment was that the web server didn't work. It should look like this according to the website, but I didn't get it. And I can't remotely trigger either, which is a disappointment. And there is a relay, so you can actually turn on your circuit with the built-in relay in the VA meter. And I could only access that via the menu. It's hard to adjust the timescales, although with a bit of practice you can overcome that. There's recording time. Yeah, there is time recording option. So as you learn it, you can overcome some of these problems quite easily. On the UI screen on the LCD, some of the parameters are hard to read. They change very quickly, and you can overcome this by selecting more of the average results. There's no programming. Perhaps this will come out a bit later, and that way you could access the Grove port. So there is a Grove port on the VA meter, but I've got no idea how to access that. Okay, so if you're interested, you can go across to M5Stack, and the shop-wise, well, we might just go and have a look at that now. So here's the unit, and its support, the description at the M5Stack shop, and there is a wiki with a good tutorial that will help you see how it works. Okay, and that's the VA meter from M5Stack. Here we have the VA meter monitoring the power consumed by the Cedino Nano computer, and there are no NeoPixels connected. So if we actually look at the display, you can see that we're averaging around about 21.7 milliamps. Now we've switched on the NeoPixels, and we could monitor the current. We'll go to the VA meter, and we can see that the average current over a minute is about 145. In this arrangement, we've got a M5Stack Fire computer, and it's controlling external hex LEDs, and the current consumed will change depending on the color of the LEDs. So we'll go and have a look at it. So at the moment we're on white, and that has the maximum power consumption. So we're on green. You can see that and now onto blue, red, and white. So when it's white, it's jumping up to about 425. Here is an alternative USB tester that could measure the current consumption. So we can see the current is around about 390 milliamps, going up to 410 milliamps at the maximum. And the LEDs at the moment are red, 390, and it jumps up to 450 when we show the all the LEDs are white. So blue, 400, red, 390, blue, we're back to white at 450. So you can see we've got green LEDs at the moment, and we'll go to blue, red, and we're on white. So you can see the white is 440.